Hello and welcome to ThinkPython Chapter 2, Part 2. As always, we'll use this link, thinkpython.com/nb, to get to the page that has all of the blank notebooks. If you've done Part 1, you should already have a notebook for Chapter 2. I'm going to go back to the notebook that we created in Part 1 and pick up from where we left off. We'll talk about the print function in a minute, but if you come back to a notebook after some amount of time, you might find that the variables that you've created and the modules that you've imported are no longer part of this runtime. In Colab, the runtime contains the state of all of the variables that you've created, modules that you've imported, and other things that you've defined. So when you come back to a notebook after some time away, you'll need to run those cells again to create those variables, import those modules, etc. I'm going to go to this runtime menu and select Run Before to run all the cells prior to the cell that I selected. You might remember that there were some errors in the notebook when we ran it last time, so I'm going to hold down the Shift button and press Enter in order to get past those errors and make sure that we've run all the cells that we ran last time. This is a chance to review the import statement, expressions and statements, and this is where we left off with the print function. Normally when you evaluate an expression in Jupyter, so for example if we type n plus 1, the result is 18. And if there's only one expression in a cell, that's fine. It displays the result. But if you have more than one expression, like n plus 2 and n plus 3, Jupyter is going to evaluate both of those expressions, but it only displays the value of the last one. If you want to display more than one value, you can use the print function. So for example, if we print n plus 2, it displays that result. And if we have more than one print statement in the same cell, it displays each of those results on a separate line. You can also print floating point values and strings. So for example, if we print math.py, it displays that result. Or we could print a string like the value of pi is approximately, and that will print the string and the value of math.py. When you call the print function, you can give it more than one argument. So for example, if we type the value of pi is, and then a comma, and then math.py, it displays the value of the string, and then the value of math.py, and notice that it put a space between them. Now I want to explain a word that I think I've used a few times, but haven't defined, which is an argument. When you call a function, the expression in parentheses is called the argument, and I won't try to explain why it has this particular meaning. Some of the functions we've seen so far only take one argument, like int, for example. I can convert a string, 101, to an integer, 101. Some of the functions we've seen so far, like math.pow, take two arguments, like 5 raised to the second power is 25. Some functions can take additional arguments that are optional, like int. We can give it the string 101 and a second argument that specifies the base. So 2, for example, means that we should interpret 101 as a base 2 or a binary number. And the value of 101 as a binary number is 5. The round function also takes a second argument, which is the number of decimal places to round off to. So round math.py to 3 decimal places. The result is 3.142. There are some functions that can take any number of arguments. Like print, we can call like this with any, comma, number comma, of arguments. Those are all strings, but they could be any type, integers, floating point values. And again, it prints all of those values and puts spaces between them. If you call a function and provide too many arguments, that's a type error. So for example, if we type float and pass a string like 1, 2, 3, point, and pass a second argument like 3, we'll get an error message that says that's a type error. Float expected at most 1 argument, and it got 2. Also, if you provide too few arguments, that's a type error. So if we call math.pow and only provide 1 argument, that's an error. And if you provide an argument that's a type that function can't handle, that's a type error too. So for example, if we call math.square root and give it a string rather than a number, we get a type error. The next section in the notebook is about comments. As the programs that you write get bigger and more complicated, they get more difficult to read, and comments give you a way to add additional information to the program to help people understand what it's doing. So, for example, if you have a line like seconds equals 42 times 60 plus 42, it might not be obvious what that statement is doing. You could add a comment which begins with this symbol, which is sometimes called a number symbol. In programming, it's usually called a hash symbol. Technically, it's called an octothorpe. But that's the symbol that indicates that everything that follows on this line is a comment. And you can write anything in a comment, any text. It doesn't have to be Python code. So we could explain here that we are going to convert a time, 42, 42, to seconds. When I run this cell, the comment itself doesn't have any effect. The assignment statement computes the expression on the right-hand side and assigns the result to seconds. In this example, the comment appears on a line by itself. You can also put comments at the end of a line. So for example, miles equals 10 divided by 1.61, and then a couple of spaces and a hash symbol to indicate a comment, and then explain that I'm converting kilometers to miles. The best use of a comment is to explain something about the program that would not be obvious to somebody reading the program. Sometimes you'll see comments like v equals 8, followed by a comment that says assign 8 to v. That's not very helpful. Someone who knows Python knows that that's an assignment statement that assigns 8 to v. It's better to explain not just what the program does, but why, or other information that's not obvious from looking at just the program. So for example, this could be a velocity in meters per second. That would be a more useful comment. The last section in this notebook is about debugging, and it points out there are really 3 kinds of errors that you can make in a program. One of them is a syntax error, which means that there's something wrong with the structure of the program. The result of that is that the program never runs. Python tries to figure out what your program is, sees that there's a problem, and it displays an error message immediately before the program starts running. Second type of error is a runtime error, and that happens when there are no syntax errors, so the program starts running, but at some point something goes wrong. Python detects that an error has occurred and it displays an error message. A runtime error is also sometimes called an exception. The third kind of error is a semantic error, where semantic means that it's related to the meaning of the program. If there's a semantic error, the program runs and it does something. It doesn't generate any error messages, but it doesn't do what you intended it to do. So to fix a semantic error, you have to work backward from the output of the program and try to figure out what it's doing. We'll look at some examples. So we've already seen that an illegal variable name is a syntax error. So for example, million with an exclamation point isn't legal because you can't have punctuation in a variable name. If you use an operator with a type that it doesn't support, that's a runtime error. So for example, the string 123 rather than the number 123, if you try to divide, that's a runtime error. Specifically, it's a type error. And finally, here's an example of a semantic error. Suppose you want to compute the average of 1 and 3. So you add 1 plus 3, and then you intend to take that sum and divide by 2. Now the average of 1 and 3 is actually 2, but the result here is 2.5. And the reason is the order of operations. Division happens before addition. So 3 divided by 2 is 1.5, plus 1 is 2.5. In order to correctly compute the average of 1 and 3, we need the addition to happen first, and then the division. So with parentheses, 1 plus 3 is 4, divided by 2 is 2. So that's it for part 2 of chapter 2. When we come back, we'll work on the exercises.